Hey everyone, welcome to part 3 of the poker assignment video. What we're going to do in the third part of this video is write our 3-pair function. We're going to write the 4 of a kind function and the straight function and full house. So we have 4 functions to go. Let's dive into the 3-pair. So before in video 2 we wrote, the last function we wrote was the 2-pair function. Which basically it compared every card in your card array against every other card by using a nested for loop, which runs one time through for every single index in the first for loop. So what we're going to do for 3 of a kind is awfully similar. If we look at kind of a 3-pair, a hypothetical 3-pair that I made here, it's similar to just finding it like a 2-pair or a single pair, except we're going to look at, we want to find basically 3 occasions where a card equals another one. And what's important is we can't confuse, for example, let's say we have 2 matching 2s, and let's say we had a matching 4 and another 4 here. Every single time we keep track of a matching pair of cards and we add 1 to a counter for a matching card, it needs to be for a unique type of number. So we can't, if we have 2 2s and then 2 4s, that wouldn't be 2 overall matching cards in this function, at least, because we need to keep track of how many matching cards we have of a single number. So what that means, basically, what makes 3-pair a unique function is that we need to initialize our counter for how many matching cards we have after the first for loop. So it resets equal to 0 every single time we're comparing a single card in the deck. So for example, let's assume that we're checking this the first index of this array, looking at the number 2. So this is where we are in the first for loop, and we set this new counter, matching cards, equal to 0, and then we jump into our comparison for loop, which looks at the next index. All right, and what it'll do is, if the index of I, so this 2, is equal to the J index here, so looking at this number, we'll increment this matching cards number. So now this equals 1 when it previously was 0. Okay, and now what we'll do is we'll test to see if we have 2 matching cards. We only have 1 matching cards, a 2 and a 2 so far. So now what we'll do is we'll increase the comparison loop to the next number, which is a 5. This 2 and this 5 are not equal to each other, and we don't have more than 2 matches. Let's increase this comparison loop again, and now we're looking at this 2. Does this number 2 and this number 2, do they equal each other right here? Yes, they do. So we increase matching cards. Now it equals the number 2. And we'll test to see if the number of matches is greater or equal to 2, which it is. And that means that we have 3 matching cards because we started at 0. So the increase from 0 to 1, so we find 1 pair, now matching cards was equal to 1. And if we find another matching card, so 3 of the same numbers, matching cards will be equal to 2. So yeah, if we find 2 matching cards after we initialize matching cards to 0 after the first for loop, it means that we have a 3 of a kind, and once we are done with the comparison loop and the first card loop, and if we haven't basically hit this conditional statement, it means that we didn't find 3 of the same cards, and then we can return false, and that's the end of our function. So I just want to compare this really quickly to the 2-pair function. So in the 2-pair function, we initialize the matching card counting variable outside of the first for loop, and this is because we don't care in the 2-pair function if all the matching cards are of the same suit, aka they are the same number. If you find a 2 matching another 2, you should increase it. And if you find a 4 matching another 4, you should increase it. So we don't need to reset it to 0 every single time we're looking at a single suit. Whereas in 3-pair, we only want to increase matching cards if we're looking, if we find 3 instances of matching numbers. So this 2 matching with this 2, and this 2 matching with this 2. So let's try to transcribe this code into our program, and we can see the first thing we're going to do is we're going to iterate through our hand. I'm just going to copy our iteration from the previous function. Great. And next thing we need to do is we need to initialize matching cards equal to 0 inside of the first for loop. And this is because we want to only count matching cards that of a unique number. So once we're looking at a certain index. So we set it equal to 0 inside the first for loop. And now we're going to use our comparison for loop. And we can take that from our earlier function, copy and paste. And then if we find a pair, we will increase this matching cards counter variable. Great. And the next thing we wanted to do is we wanted to check to see inside of our comparison for loop if we have if matching cards is, you can check to see if it's equal to 2, because we'll know that if we have a 3 of a kind, that it's equal to 2. And if this condition is hit, we know that we have a 3 of a kind, and we can return a Boolean already for this function, which would be true. Now let's close all of our for loops. And we know if we have gone through this entire process and we didn't find 2 matching, matching cards didn't equal 2, then by this point in the function we can return false because we did not find a 3 of a kind. Great. So let's move on to 4 of a kind now. It's going to be similar to 3 of a kind, but guess what? How many matching cards we're going to have now? If you answered 3, that is a good guess, because we will want essentially 3 matching cards of the same suit. So let's basically unpack the 4 of a kind function. So we're going to do something similar where we iterate through a hand, and then we initialize a matching card number for each number we're looking at. So, for example, if we start with the number 4, we're going to compare 4 against every other number in our deck. And we won't find any matching numbers for the number 4. So now we'll move on to the next card in the hand, which is 2. And then we reinitialize matching cards to 0 because we're looking at a new number. Okay, and then in our comparison loop, we compare 2 against the next index. Oh, they match, so we'll increase matching cards by 1 when we find a matching pair. And then we'll compare this 2 against the next index, which matches, and we will increase this matching card to 2, and then we'll compare this against the final index in the array, and we find another match, and we'll increase matching cards again for the number 2, which we're looking at. So basically, if matching cards is equal to 3, we'll know that we have a 4 of a kind, and we'll return true. And if we finish this entire process without finding matching cards equal to 3, we'll know that there is not a 4 of a kind, and we can return false by the end of the function. So let's now write the 4 of a kind function. So basically, we just know that we need to find, it's identical almost to the 3 of a kind function, but we need to find 3 matching cards. So what I'm going to do is I'm just going to copy and paste everything from the 3 of a kind function, and I am going to put it inside the 4 of a kind function. Great. So now what we do is we basically just want to check if we have 3 matching cards. And that's basically it, because that's how many would constitute a 4 of a kind. And yeah, so that's essentially the 4 of a kind function. And keep in mind, the reason that we find 3 matching cards is we're starting at one number where we set matching cards equal to 0. And when we find another matching number, now we increase matching cards to 1. So then when we find the third pair, matching card equals 2. And then when we find the fourth part of the pair, matching cards equals 3. So it can kind of seem confusing that a 4 of a kind, we reach a 4 of a kind when matching cards equals 3. We reach a 3 of a kind, for example, when matching card equals 2. It's because we're starting at 0 on the first card in the matches. So now let's move on to the straight function. So a straight is a little bit more complicated in that it requires a number of pretty long portions of code. So what I mean by that is, in order to find a straight, the first thing you'll need to do is, in your array, you'll need to look through the entire array and figure out what is the lowest card in your hand. And then, once you've determined the lowest card in your hand, you'll want to see if you can find the next 4 consecutive numbers. So, looking at this array, we see 2, okay, is 2 lower than 3? Yeah, 2 is lower than 3. Is 2 lower than 4? Yeah, 2 is lower than 4. Is 2 lower than 5? Yes. Is 2 lower than 6? Okay, so 2 is the lowest number. And then what you'd want to do is, we're going to see if the next 4 consecutive numbers, so basically we found this low number of 2. We want to see if we can find 2 plus 1, 2 plus 2, 2 plus 3, and 2 plus 4 in our hand. And that would constitute a straight. Basically just a five consecutive numbers in a series. So once we find if there are 4 consecutive numbers from the lowest number, then we will know that we have a straight. But let's first start with the first part of the code, which is to first find the lowest card in the hand. So it's going to be awfully similar to the high card function, where we are finding the highest card in the hand, but instead we're going to be looking for the lowest card. So we can actually just go to our high card function, and what we want to do is we'll just essentially copy this code, but we want to basically find the lowest card. So we'll be in the comparison, we'll be looking at each index in the array and seeing if it's lower than the low card. So what we can do is we can go to our function for high card, and we can copy the first, everything excluding the return statement, and we will put it in the beginning of our straight function. So this is our goal. First, find the lowest number in the hand, and we'll call this number low. And so basically what we want to do is if our card that we are looking at in the index, in the array, is lower than the number we initialized to be the low number, so just the first number in the hand, then we will reset and update the low number to whichever number in the hand we found that is lower than the low variable. So just make sure that all of, okay, missing it. Great. So by this point in the function, we will have stored the lowest card in a hand as the variable low. Awesome. So the next thing we'll want to do is we want to see if we can find the next 4 consecutive numbers starting from the low number. So we want to see if we can find then we want to see if we can find the next 4 consecutive numbers, which are low plus 1, low plus 2, plus 3, low plus 4. So, for example, in our straight hypothetical array, the low number is 2, and we want to find low 2 plus 1, which is 3, 2 plus 2 is 4, 2 plus 2 is 5, and 2 plus 4, which is 6. So the first thing we'll want to do is we're going to look, basically, we're going to use 2 loops. The first loop is going to be just an I variable loop, which is going to add 1 plus 2 plus 3 plus 4 to the variable low. So we're just going to create a for loop in which the counter variable I is starting at 1, and it will iterate by 1 until it is equal to 4. And what we're going to do is we're going to end up adding I to the low variable to see if we can find that number in the card array. So let's first create initialize a for loop that will add the next 4 consecutive numbers to low. And we'll do that by creating an I for loop where our counter variable is going to start at 1 because we want to first add 1 to the low variable. And we want to do that until the number 4. So we can say while I is less than 5, or while I is less than or equal to 4. So it includes that 4. Then we'll add 1 to I each time. Great. So now the next thing we'll want to do is we're going to want to look at each card in the hand. So we're going to want to iterate through the hand, and we know how to do that. We'll just copy our for loop from any function. So great. Now what we want to do is we want to see if we can find low low plus I, because this for loop will iterate from 1 to 4 in this fashion, and we're going to look at each card in the hand. So let's say we're starting hypothetically with this number 2. We're going to want to test to see if we can find 2 plus 1 in the hand. So for example, we're going to look at every single card in the hand. Can we find a number that's equal to 2 plus 1? Yes. Okay, we found the number 3. That's great. And if we end up finding that first consecutive number, we're going to set a Boolean variable equal to true. And then if we find that variable, we don't need to, for example, continue to look to find another consecutive, another low plus 1. We can just break out of this for loop that's looking at each card in the hand, and then we can increase this outer for loop, to see if we can find the next consecutive number, which is low plus 2. So then we restart this for loop, and we'll try to find, when we find low plus 2, which is equal to 4. So we'll look at every single number. Oh, we found a 4 here. Great. And we can keep the has straight Boolean, and we can set it equal to 4. Or sorry, equal to true. Basically, what will happen is after we get to the 4th consecutive number, has straight should still equal true. If at any point after we have looked at each card in the hand and didn't find the consecutive number we were looking for, we can test to see if has straight equals false, then we can return false. So this actually needs to be, there needs to be another. So after we have looked at each card in the hand and we didn't find that consecutive number we were looking for, if has straight is false, we'll know that, okay, we didn't find that consecutive number, thus the straight doesn't exist. So that needs to be after we have closed this for loop. Great, so I think we have enough to continue writing the function. So let's go back to the straight function, and one thing we did not do yet in here is we need to create a Boolean variable that will test if a consecutive number was found, and this will be called, has straight, or straight exists. But when we first start, we'll set it equal to false. So now we're going to look through each card in the hand, and we want to see if we can find the consecutive number. So test to see if the consecutive number, which is low plus I, exists. So we're going to test to see if cards at cards index is equal to low plus I. And keep in mind, so I it's checking all 4 of the consecutive numbers. So low plus 1, low plus 2, plus 3, plus 4. And if we found the consecutive number we were looking for, we can set has straight equal to true. And so basically, if we finish this loop and on the 4th number this equals true, then we'll know we have found all four of these consecutive numbers. So, however, if we finished looking through a hand and we didn't find that consecutive number we were looking for, has straight will be equal to false since we didn't hit this condition. So after this for loop, the iterating through the hand, we should test to see if has straight is equal to false. Because if it is here, then we know we didn't find the consecutive number we were looking for, and thus the straight does not exist. Awesome. So let's make sure that we have closed off all of the for loops. So this one is the end of the I loop. And right here, this is the end of the card loop. Great. And so if we finish this entire process and we did not return false here, we'll know that the straight exists and we can return true, because has straight will have been true by the fourth consecutive number, and we will have not returned false automatically because we didn't hit this if condition. Whew. Okay, so that was a really, really long function, and might want to pause the video, take a break, get a glass of water. I'm going to take a sip of tea really quick. Okay, and now we're going to start the full house function. So I am not going to program, in this live coding session, the entire full house function. But instead, I'm going to help everyone break it down into a number of parts. And what's interesting about the full house function is that we kind of have programmed a lot of the elements for this function already in the pair function and the three of a kind. Because what is a full house? For reminders, a full house consists of a pair. So for example, a 4 here and a 4 here, and then a three of a kind of a different suit. So we have 3 2s, 1, 2, 3. So here are the notes that I'm going to give everyone. The first thing you'll want to do is you're going to want to find a three of a kind. And you can largely recycle the code from a three of a kind, a three pair function. One thing that you'll need to do, in addition to just using the three pair function, is you're going to want to keep track of what number you found 3 of in a temporary variable. And you can start off, some temporary variable called three of a kind and set it equal to 0. So once you find the 3 pair, you want to store whatever number you found, 2 matching numbers in total, into this temporary variable 3 of a kind. So for example, if we found 3 2s, we'll want to store the number 2 in 3 of a kind, because the next part of our code is to find a pair of cards that is different than the 3 of a kind number. So the pair of cards is 4 in this case. So we want to also check to see if the pair that we found is different than this number, because it needs to be a different suite. For example, it's a 4. So here are the notes that I'm going to give everyone. First, find a 3 of a kind and keep track of that number in a temporary variable called 3 of a kind. And then you can copy and paste the code from the 3 pair function. And once you've done that, if you don't find a 3 of a kind, you can return false and just finish your function then. So how will you know that you didn't find a 3 of a kind? Well, once you have stored the number that you found 3 of a kind for, it will be a different number than 0. So if 3 of a kind is equal to 0, by this point, you can return false. And then the final thing you'll want to do is look for a pair of numbers that is different than the 3 of a kind number. So you can recycle the code from the function a pair, and basically so let's look at the a pair function. So in the a pair function, you're just looking through every number in a hand, and you use a comparison loop, and you'll want to test to see if you can find a matching pair of cards. But then you're going to also want to add a condition that basically double checks that the card at whatever index, so you'll add another condition here that'll be and that the cards at the index you're looking at is not equal to the 3 of a kind number you stored earlier. So you're going to need to add another condition here to make sure that the card that you're looking at is not the same as the 3 pair number. And if you hit this condition, then at this point in the code, you'll know that you have found the full house. So you can return true at that point in the a pair function. So in this part, you can return true, and then if you didn't find the pair, then you'll return false, just like in the pair function. So full house essentially is just, it has 2 sections. The first part is finding a 3 of a kind, and then the second part of the function is finding a pair. And then you can return false if you didn't find that pair, because it wouldn't be a full house. Okay, so really long video. Thanks for sticking it out, and please respond if you have any questions, and good luck.